Hello, I'm Shane in Sweden, and in this series of presentations, we've been looking at how we can investigate a simulated data breach using Splunk. In the last part, we looked to see if we could find any evidence of the adversary succeeding with some sort of exploitation activities. And we did indeed discover just that. We discovered they had gained access to the admin account of our content management system. And in this video, we will try to discover what they did with that access. So this video will cover the installation and action on objective phases in the Lockheed Martin cyber kill chain. And remember, we know one of the objectives, which was to deface the Wayne Enterprises website by changing out the main image. Now the question is, can we come up with a reasonable timeline of what they did and when they did it? So let's get started. If we look at the story so far, we know that there are two external IP addresses that seem to be engaged in suspicious activities. There seemed to be a lot of focus on the Joomla content management system on our web server. We saw scanning and different sorts of injection attacks. Then from another server, we saw an attempt to brute force the password for the admin account, which we think succeeded. And once this server had obtained the correct password, Batman, we could see that the same password had been used by our other server. So the question is, what happens next? Well, let's get back to Splunk and see if we can find out. Okay, here we are back in Splunk. And here is our two occurrences of where they used the password Batman. And we can see that one occurred at 2146 and the other one occurred at 2148. Okay. So this was the machine that did the brute forcing, and then this is the machine that used it afterwards. So what we want to do is find out what happens after 2148. So since our focus is going to be on that, we're actually going to change our filter here, which you can see we've always had on all time, and we're going to set a date and time range. Now we can see it happened on the 10th of August 2016. And they used this password at 2148. So the question is, what happened in the system after 2148? What information do we have in Splunk? Now there are two ways we can look at this. We can look at this from the terms of information flows, network traffic, information flowing between our soon-to-be defaced web server. Okay. Now we know that there is that they somehow replaced the image on our main web page with a new image. Somehow that image got onto our server, and perhaps network traffic can help us here. So there's several sources we can use, things like stream data, especially stream HTTP would be good. We can perhaps use our Suricata information, perhaps the information on our IIS web server, and even perhaps our FortiGate firewall. All these things might contribute information about what happened in our network streams. The other thing we might want to look at is what were they actually doing on their web server after they gained access. Okay, were they doing any changes? Were they installing any programs? Was the server talking to anything? And for that kind of thing, it's quite useful to look at Windows events. And we have here sysmon and other Windows events that we can look at. Okay. Now, Windows events, Windows generates an awful lot of events. So you really want to try filter or narrow down a search. And a good start here is that we're filtering down to a very short time interval. If you look at the graph, you can see everything happens over a fairly short interval of time. Okay, so we have traffic, data we can use to examine traffic. We have data we can use to look at what's happening on the server. So let's start with the traffic picture. We can see that the second password was used at 2148. So let's look at posts from our attack machine 42 to the web server after 2148. So we know what our destination IP is. It's our web server. We're going to look initially here at web posts. And we know what our source IP is as well. We're going to look at the traffic from the machine that used the password last. And we'll extract out that. We can extract out the fields that we're interested in, which would be the time. We want to see what happens in our timeline. Let's look at the URI that was called, the form data maybe, and we'll sort that on time. Now we've reset our time window here, so we're going to put that back to date and time range. We're going to do it after the 10th of August 2016 and after 9:48 in the evening. So let's search for that traffic. Now we're getting quite a lot of traffic there, but we can see quite a lot of this is the search component, which we identified earlier. It's less interesting at the moment because we identified that as attempted injection attacks. So let's just filter that bit out, and we'll just copy the URL. And we want the, we'll put in a new filter here. We'll do a new search filter using the Splunk search command. And we're going to search on the URI not being equal to the search component. Okay. And let's run that. Now we've got a much more restricted data set returned, just 17 posts. Here we can see was the login to our administrator's login page. And immediately we can see that there is quite an interesting action here, an install of a script. And it looks like it's a PHP script. Now if we go down, we can see that this PHP script is encoded. But I think Splunk will actually even be able to, yes, indeed. Splunk can, in fact, do a lot of the decoding. Unfortunately, we can see that this script is still obfuscated. To make it hard for us to understand, exactly what's going on here. But we can see HTTP accept language, server, HTTP refer. This looks like some sort of web request, web shell, web program. I'm not sure. We'd have to look at it further. But it's clear at least that they're trying to install, or they installed some sort of PHP script. And then afterwards we can see that there are a number of actions using plugins to Joomla. And here it looks like they're trying to extract the contents of directories. And here we see also an upload event, which looks very interesting indeed. And if we examine the information for that in a bit more detail, let's go down. And again, we can see that it's similar to the other PHP script. This seems to be some sort of uploading utility. Yeah, it's an uploading component to help uploading of files to our content management server. Okay, so we can see that the adversary is trying to install uploading components to help them. And we can guess that they maybe want to upload or install something, either perhaps that image that we saw on the website, or perhaps some sort of malware, some sort of program, which would be interesting to check. So let's see if we can find any internet traffic which has mentions a program. Now we're in a Windows environment, so programs are usually batch files or scripts or PowerShell scripts or perhaps just a plain old exe. So we can test that first. We'll just do a very simple search, see if we can find any exes in our traffic that happened after the attackers had logged into our Joomla content management system. And it looks like we're getting some matches. This seems to be binary data, binary encoded data. And if we look down through the files, we can see we've got part file names here. And look, we can see there are two files here, another PHP script and a program called 3791.exe. So what is happening with these two programs? Let's look at 3791exe first. So we can just look at the whole index, because we've now got a very specific piece of information to play with, and see where does this program turn up. Now here we can see we've got information from FortiGate from our advanced firewall, and you can see the event type is infected, and it's identified this file as a piece of malware, and it's given us a hash for that file. And this is very useful because we can search on that hash and immediately we'll get a match. So here we're getting a match on VirusTotal, which has identified this file that we're loading up as a piece of malware. Okay, so if we look at the first field was from our FortiGate firewall. If we look at our other traffic data event here, we can see we've got a lot of binary data. And in fact, actually, you can see there's an action there, upload. If we zoom in on this event, we can see that there were two files loaded up from our attack IP address. And we can see from the form data that that was the two files loaded. And it was done using our Joomla content management system. Okay. Now, as we mentioned earlier, we can either look at events through from a perspective of network traffic, HTTP stream data, information flowing through our intrusion detection system, the IDS, the Suricata, or even information coming through our firewall. Or we can look at Windows events and what's happening on the server, what's actually happening to our files and stuff. So maybe it's time for us to now have a look at what sort of data we have for what's happening on our actual server running our Joomla system, and try to see if the attackers are doing anything in Windows with our web server. So we're going to add sysmon data source to our query and see what sort of information we get there. And we can just take a quick look at some of the events we're getting. So here we're getting an image load with where our 3791.exe is involved. And we can see actually that the 3791.exe file here, it's loading winsock32 DLL, which suggests that this program, this virus or this malware, has some sort of network capability. And we can see that this was actually running inside the Joomla directory. Now, presumably the attackers are running their commands, the 3791, from that current directory, so we could add that to our command filter, and we can look down and see if we've got the current directory here. It doesn't look like it, but we've got a lot more fields. And here we can add a couple of more fields. And let's add those just to our selection. Now we've got current directory, and we can see we've got two directories that are coming up, and we're interested in our Joomla because that's where our 3791 program was running from. So if we filter our events on that catalog, And if we try to make the results a bit more meaningful by using our table command, so we're interested in the time, we want to see the timeline and the way things are happening, and we're interested in the command line. So let's get that up as well, command line. And also in Splunk, as you can see, if a program is running another program, yes, there's a parent command line. So let's get that up as well. Because if you're getting something like a console process running another command, you might want to see what it is. And let's get, there is MD5, is there a SHA? There's a SHA-1 and SHA-256. Let's get up some sort of hash. And that should be perhaps enough. So we're going to pull out these fields and we're going to pipe that through to sort it on time. Okay, and we can see we've got 4 events. So here it looks like we've got the server script, the PHP running to start up the 3791, and then we're running 3791 inside a Windows command line. And I'd be interested to see which account these are all running under. So if we just add user to the mix, okay, we can see it's the anonymous guest, the internet information server anonymous guest user that's running all these accounts. We're not getting any hash values because we've misspelt the variable. Let's just change that. And here we can see again we're getting that hash value for the file that we saw under VirusTotal. Okay, so we can see that the program was running several times shortly after being uploaded, and we know that it has some sort of network capability. The question is, can we see this program involved in some sort of network event? We have these occurrences of this program being run, and we saw earlier that it had some sort of network capability. Question is, do any of these occurrences of the program when it's running, is it actually trying to make contact with anything from our web server? And if we go back to the previous query where we had all the events, so let's see if we can recreate our query here so that we're actually capturing any Windows events that involve network. And we can do that by looking at the signature. So if we take away the current directory there, and look at the different signatures we're getting, and we can sort that by time. Right, you can see we're mostly getting image loads and process creates and image loads, but here we've got an event which is a network event, and that happened at 9:56. So let's look at that event. What can we see here? We can see very interestingly that now we've got our web server, which is contacting a remote, the same remote address that was carrying out brute force attacks. And here we can see the name. It's actually an image running on Amazon Web Services, and it's our program here that we've seen before. So we can see that our web server has made contact using TCP transport to the remote server belonging to our attackers, presumably to retrieve something or to obtain new commands or command and control, or perhaps to fetch a new program or something else. So let's try get a complete build of what's going on now with this program. We've got the signature equal to network connect, but we also want to see when it's just running normally on the server. So let's put signature equal to process create. And we'll do the same. We'll pull out table and the time and the user and the command line. Let's see, we can have the image and the signature, and we'll sort this on time. we've got a mistake here. Let's see, table. Oh, our date has reset. Hold on, let's go back to what it should be. It should be since 10th of 8th. Let's see, 21:45. Don't want to miss any events. Apply. Okay. 3791, we've got starting up a console and a command that's running, and then 3791 makes contact, and then the command is running again. These are unique processes. We can get rid of that command line. Spelling mistake there. Now, it'd be useful if we could see what some of these commands are doing. And one way to do this is if we add in the process squid. This is unique code in these type of Windows events that identifies each process if we spell it correctly. So we've got some processes here. Now, under the events, you can have a process squid as a process squid of this program, or it can be the process squid of a parent. So perhaps we can see if these are parents with their GUIDs, what are they running? What is the children processes that are running under them? So I can just construct a new command using these process squids. So we've got the same as before. We've got the index, we've got our sysmon source type. We're looking for the parent process which has any of these process squids, any parent process which is running. Can we fetch out the command line and the image and stuff that's running? So if any of these commands are running something else, perhaps we can see what's happening. And we've got our time filter set correctly. So let's see what result we get here. Now this is very interesting. So you can see that the program 379 was running. And then we start a console host which runs a command. We can't see, there's no child process there, but here we can see we're doing a ping against a remote server, and then we're doing an NS lookup. So we're checking to see if that server is alive and then looking for its IP address, presumably to make contact with. So now we've actually got a domain address for one of the servers that belongs to our adversaries, prankglassjumpingcrab.com. And then we could obviously do this NS lookup and fetch that IP address as well. So we can see via the command line that the 3791 that our processes now that the adversary had installed were making a connection to our enemies, our attackers' domain. So we know that our web server is reaching out to this attacker's domain. Question is, can we see any traffic? Can we see any stream web activity between our server and the enemy's system? So let's look at web traffic. But this time, for once, we're going to use as the source is going to be our web server. And let's just check the date range. The time range is incorrect. Let's just fix that. And we want this up before 21:45. So has our web server had any contact with, so all the other communication we've been looking at has been incoming. Now we're going to look at outgoing, where we actually, our servers contact the attacker servers. And we see immediately we get a hit. With, it looks like some binary data. And there's not much information here. So let's go back to our event and see if we can add in some more information from the other fields. Let's scroll down and let's see if we've got a, what are we on? We're on smart mode, that's correct. Here we've got the URI. Whoa, and here's a very interesting URL. We put that into the filter. We've got two events here. Now we know that our web server was defaced using an image, and here we have an image pertaining to the attacker. And we can see that our server did a get, fetching a JPEG image from the attacking server. Here's our source, our web server, and it did a get. And this is still the same, yes, fetching the JPEG. So we can see we've captured on the event here now where our web server has, presumably through malware loaded up onto our computer, fetched an image from the attacker server, fetched it back to our web server. Here we can see that get in process. And this is happening at 10:22. Hold on, let's just get the time and the URI. (22:13), 22:06, two different times. And what was the source? From our web server. Okay, so we can see now that we've fetched back to our server a web image. What happened to that? What happened to that image afterwards? Well, can we see the user? Earlier on, we saw the user was the iUser. That's not in the stream data. Earlier on, we saw that it was the iUser who was performing this. So one thing we could do here is go back to our Windows data, perhaps, or search anywhere and see if we can find anything pertaining to what that user was doing. What was the full name? I think it was authority user. I'm just going to go back to an earlier query we had where we could fetch up the users. Here we have it. I'm just going to put him into the query. So there it is, users equal to that. Let's just take away any sort of source information. We're interested in anything he might be running. So let's pull out the time and any sort of command line data we have. Which we should have maybe something from our sysmon data or other Windows events. And we'll sort that on time. Let's see if we get anything here. Let's check the date range. Let's go from 9:45 again, as usual. Okay, so let's remove the 379.1.exe from the filter. We want to see all events. Now remember, we saw the 3791 program fetched the image, Poison Ivy image, at 19 minutes past 10. So we're really interested in what's happened after 22:19. But we can have there's quite a few things going on here, so it's worth having a look. So we have it carrying out an echo command, and then it's doing a directory with a redirect of standard, is it standard out, standard error. Then it's running a Unix directory, and then a Unix network configuration. So 3791's running, and it looks like, interestingly enough, it looks like they're trying to do some sort of net share. And then it starts pinging the domain. So we're getting up to the point now where it actually grabbed that image. And then it did an NS lookup. And here we go, around this time is when it runs the command to fetch the image. So what happens after that? Whoa, look, 1 minute after that we have a move, and it's moving the image from 1 to 2. And then if we go down a bit further, we can see here it moves the to image to I'm not Batman.jpg. So I'm guessing that this is the event where our website was actually defaced, being carried out on our web server here. And we've got some hashes, which would be useful if we were building a full forensic proof for a criminal court case. And we can see this move process is running by the IE user under our web server using the PHP CGI engine. So here it is. This is where our web page was probably defaced. So we could obviously go into a much more deeper analysis if we wanted to create a criminal case with forensic level of evidence, but I think we've actually built a fairly good image now, a fairly good timeline. We have a fairly good understanding of roughly what went on our web server that evening. And this really shows the power of Splunk when you have a number of different data sources. So back to our story. We had some scanning and injection by the 148.42. Then we had the brute forcing of the password by 114. Then we had the uploading of the 3791 malware. And finally, we had the fetch of the image from the 114 system, which was then copied and moved to replace the image for the image on our homepage, on our web server, defacing our website. So there we've done a bit of incident investigation using Splunk. And I hope you can see the power of Splunk in this type of investigation. I think we've also shown how it's useful to have the Lockheed Martin Cyber Kill Chain as a model for investigating this type of incident, and how we can use Splunk data to look at quite a few of the stages that are involved here in the Cyber Kill Chain. If you want to try out these experiments, or if you want to try this investigation yourself, the data is available online due to the very nice people at Splunk. So feel free to have a look at this video, and then feel free to try out these commands on the system by yourself. Thank you very much, and I hope you enjoyed this.